Hello, I am Shrunija. So I'm going to speak about my topic of a final project, ADTA 5550. So in this, I'm going to speak about the final project where the main goal is to create and train a CNN that can identify one of seven facial expressions from an input image of person face. So it can tell about whether the person face is angry or afraid or disgust or sad or surprised or it's just a neutral. So for using of this architecture, TensorFlow is used in it, and different types of collection of labeled facial expressions photos were used for the training purpose. Um, so for this, in the main data set, we have taken for 48 by 48 pixel grayscale photographs, which were developed by the Pierre Luc Carrier and Aaron Curl with the goal of recognizing emotions from face expressions, where face expressions can be recognized by using these photographs. So it totally contains of 28,709 training examples with labels for one of seven emotions. Like there are total of nearly 29,000 examples, which has a different types of emotions in it. And this pixel image will be ranging from 0 to 6. So this basically this test is divided into two subsets where it will be having a final set of same size for competition outcomes and a public set of 3,589 samples. So after the training purpose, there will be the set of two where one is for the competition outcomes and another one is for the public set. So for the enabling of a uniform analysis and comparison, these photos have been standardized to guarantee that the face is centered and takes up the same amount of area throughout the dataset. So this mainly the datasets are in the CSV file description, where the image pixels will be ranging from 0 to 255, and the range of image pixels is between 0 to 255, and the pixels will be of in the form of any array form. So not only that, the data set which I have selected has rows of 784 and 785 columns. So the first column is the label of the image, and we can see that the second column is the image of a pixel values. Here I have given a path for the data folder where I have taken the data and used it at first, and then I have loaded the data in it, where we'll be using the import file and open, and then we can have all the batches from different training data where the data is divided and testing is used. Um, so that for the next thing, there will be like zip of all data directions of data one unpickle. These are the used, and this will be the outcome where it will be using for the batches. We can see that. And next, we can have the meta batch where one of the uh, divided batches we can get, and you can see the outcomes as automobile, bird, cat, deer, dog, frog, horse, sheep, and truck. And these are the different types of batches in the data. So, and for the next thing, this data set is submitted in the remote server, where after downloading it from Canvas, I have taken it as a new subfolder called this CIFR dot underscore 10 underscore data, where I have shown and uploaded it in the IPMB file as well for my testing. And next from that student, I have taken into the student's local computer. I have uploaded all of these data sets, data files to newly made subfolder in the remote instance. So in a similar type, I have downloaded this data and loaded it into my computer. Then use the SFTP TPs to step to upload the data set to my distant server. So after uploading this, I can do the testing methods and everything. So next, for building, training, and testing of CNN, I have used this CIFAR 10 data sets. So for this data set, it is a collection of images where these are used to train machine learning and computer vision models. So this data set usually contains over 10 classes of images, like there will be of air, there can be of an airplanes, dogs, ships, and different kinds of images. So in this, the TensorFlow AI framework is used, where train a conventional neural network is used on this data set. So then the test the trained CNN on new images. To have the training of this process, first I have done is to load the data set which I have shown here. After that, we can by using different types of TensorFlow data sets libraries. Uh, I have used the uploading of the libraries. Then uh, I have done the pre-processing of the data where TensorFlow data augmentation is used. Then for the development of a CNN model, I have started this process. So this TensorFlow API is used in this step to have the training process. So after the CNN model is built, we train it on the data set where we use the model checkpoint callback to save the weights of a training model. Then, as we have seen, the different batches and the metadata are uploaded, and where we will be getting this. So, we have different types of examples in a single images where I have taken a mat plot lib and I have given the one of the batch name and I have reshaped the size according to the data set, and I have given all the plots, and I have used the tensor flows and all. And as we can see, we can get the image like this by giving the different types of pixels. And not only that, we have a different types of I have selected different types of batches and given this. And now, for comparing the conventional neural network performance, we can see that there are many ways to compare this process. And I have taken the after running through 313 batches, the model's accuracy was at 60.59%, and its loss was roughly like 1.1407. So basically the model's performance is gauged by the loss where lower numbers correspond to the higher performance. So mainly what counts as the accuracy is the percentage of the test, so that we can have the model mm, properly categorized. In this instant, the model 60.59% of the time accurately anticipated the test data's result. So in this, I have shown the accuracy of the model. And for the comparing of this, there are many ways to compare the performance of different types of neural networks. So mainly some common ways are to compare the classification accuracy and the number of training examples required or amount of time required to train the model. So the mainly this part aims to compare the performance of conventional neural networks on the MNIST and CIFAR10 datasets, where these will be trained as a CNN on each dataset and compare the performance of the models on the held out test, where these are the used as a CNN's performance. The CNN will perform before on the MNIST dataset and then the dataset which I have selected, because this dataset is simpler than what CIFAR 10 datasets. So it is more complex. So the CNN will be performing well in this dataset compared to other ones. So for the performance. The model's performance is generally improved as it trains as seen by the graphs growing accuracy and declining the loss. To increase the model's predictive power, it may be necessary to optimize it more or add more training data or reevaluate its design. So it's crucial to remember that the accuracy is still below 50%, which is not a very high level. As we can see, the accuracy is still below the 50%, and to improve this CNN, we can change by using the activation to sigmoid. And these activation functions are a key component in the CNN process, where the sigmoid function is one such activation function used to improve CNN's performance. The sigmoid function is a non-linear function that squashes the input values into a range between 0 and 1. So there are different types of functions, but the using of a sigmoid function can be use of more points where the range is between 0 and 1. And the function is useful for CNNs because it can help the network to learn complex nonlinear relationships. Additionally, the sigmoid function is differentiable, where it is used in the backpropagation to train the network. So it is this function is different from other functions as it will train in the backpropagation to train the network. And so that for the main accuracy we can get a better accuracy in future. So the process which I have done here, we can see that different pictures are assigned in different ways. And now for supporting of the functions to rearrange the data, these encode one hot encode values are used. And for the use of first conventional layer, all the training images were uploaded and given for the training, and these labels were given so that the images can be loaded and we can see the process. And for using of these following, we can images, we can have the setup images where the after one batch, the next batch will be uploaded. And for developing of this process and functions, the CNN model is best for the having the better accuracy results. And to have this, we will be first filterizing the length, width, and other process, and what is the weight and the height of the image, and what of the shape can be used, and is there any process we can upload it, and all. Next, for creating the different layers or any are there any inputs and outputs to be given, and is the padding the same or not, or is the size of the image everything is same or the not, we can see. And for using of this conventional neural network, we will be using these TensorFlow. For that, I have first imported the TensorFlow as TF, and then I have given all the pixel size and the shape and the row and array of it. And next, for that, I have created a placeholder for the labels. So for firstly, I have created a first conventional layer where we can use the filter in the shape of the image. Then after that, I have created a second conventional layer. Then I have flattened the data where we can reshape it if at all the image is not in a perfect way or any other thing. We can reshape the model and used it according to the fixing of a shape and the size of it. And using all of these, we can then train and test this CNN model on the data set. So for this, we can give the range of the batch of each images and collect the data, and then we will be adding different matches or different images to test them or to compare them. So for the matches and the interviews of these integers, we'll be calculating accuracy while using the mean of those matches which we have taken from the images. So this testing of the model with each step will be using and drop out, and because we can find the accuracy better than the others. So finding of the accuracy, we can get the accuracy values of each thing where at what step and what is accuracy. Like on step 100, the accuracy will be like 0.3. On step 200, the accuracy. So we can get the accuracy like this until we go under 4,900 steps. We got 0.67 as the accuracy. Images where the after one batch, the next batch will be uploaded. And for developing of this process and functions, the CNN model is the best for the having the better accuracy results. And to have this, we will be first filterizing the length, the width, and other process, and what is the weight and the height of the image, and what of the shape can be used, and is there any process we can upload it, and all. Next, for creating the different layers or any are there any inputs and outputs to be given, and is the padding the same or not, or is the size of the image everything is same or not, we can see. And for using of this conventional neural network, we will be using these TensorFlow. For that, I have first imported the TensorFlow as TF, and then I have given all the pixel size and the shape and the row and array of it. And next, for that, I have created a placeholder for the labels. So for firstly, I have created a first conventional layer where we can use the filter in the shape of the image. Then after that, I have created a second conventional layer. Then I have flattened the data where we can reshape it if at all the image is not in a perfect way or any other thing. We can reshape the model and used it according to the fixing of a shape and the size of it. And using all of these, we can then train and test this CNN model on the data set. So for this, we can give the range of the batch of each images and collect the data, and then we will be adding different matches or different images to test them or to compare them. So for the matches and the interviews of these integers, we will be calculating accuracy while using the mean of those matches which we have taken from the images. So this testing of the model with each step will be using and drop out, and because we can find the accuracy better than the others. So finding of the accuracy, we can get the accuracy values of each thing where at what step and what is accuracy. Like on step 100, the accuracy will be like 0.3. On step 200, the accuracy. So we can get the accuracy like this until we go under 4,900 steps. We got 0.67 as the accuracy. So after loading the data sets, I have run through the different types of batches where the model accuracy was around 60.59 percentage, and it has even the loss where it was nearly up to 1.1. In this screenshot, we can see that the test function was used in the model where the loss was up to 1.1407, and accuracy was around 60.59 percentage. So this model performance is used by the gauge of the loss where lower numbers corresponded to higher performance. So which cost and counts as accuracy is the percentage of the test set that the model properly categorized. So in here we can see that I have loaded the data in it, giving the different types of batches and different types of images in it. After loading the batches, we can see that each batch can be of different types, where it can be of airplane, automobile, bird, cat, deer, and different types of. We can have even the visualizations of those, and there will be total up to nearly 3,000 or 2,900 of the samples in this. So we can see that the images of how the pixels and how the TensorFlow and how CNN runs here, we can get the output of the images like this. And by using these images, we can use different types of conventional layers, as we know that the CNN has different types of layers. For that, first we will make it ready for the first convention layer, where we can see that all the data and the images will be self-trained, and we can label those images and we can test them. So for setting up of these images and the labels, we will, after setting up, we will print those labels and the images of these. And this images will be trained, and the data will be used, and all the data batches will be trained, and those trained batches will be uploaded in this. And after uploading of them, we can just print out the values of where test images and the labels can be given. So now for this setting up of an image, we will be using Zipper helper setup, where the next batch will be used automatically after the first batch. And for that, we will be building up and train, and we'll be testing the CNN model. So for that testing of a CNN model, we can see that half the CNN performance will be compared. So before the MNIST and the CIFAR10 datasets can be compared, where MNIST is an easy process and it can be done easily compared to CIFAR10 dataset. So that's why CNN model can be the best use for this data sets, which can be more complicated, so that we can get easy accuracy and correct prediction for the results of this. And for building of these, we will be using the creating a conventional layer first. Then we will use the shape methods, filter, and we will describe and use of the weights, lengths, and all the padding values and all. And for that, we will be using the conventional layer outputs, and we will initialize the weights in the filter. So next, after creating a CNN layer, then we will be using a review layer. After the review layer, outputs will be created, and the pooling method. And for this pooling layer, we will be giving the strides and how many inputs are there, how many outputs can be used, and how the size can be remodeled, like differentiated and all. After creating those and initializing them, now we will be creating and differentiating the values and initialize the weights of it. And next, we will be using inputs and labels, where we will be giving an X and Y values as a true. For that, we will be giving a placeholder for the inputs, and then we will be taking an array values in it. And then we can now have the values which can be used. Like we will be having a placeholder. These placeholder can be having a shape where it can be of a different pixel size of an picture. So for the first layer of conventional layer, we will use the shape, and then we will have the output and filter of that shape. And next, we will have a reduce spatial size of that. Next, then after completion of a first conventional layer, we will be creating a second conventional layer. And after that, having these two conventional layers, we will flatten the data, where these are called the second pooling layers. And for creating an output, these feeding output and pooling inputs will be taken and initialized into this in this type of a layer. So after creating this, we will be having a dropout layer in this method, where the placeholder will be developed, and the setting of the input to 0, so that it would be ignored in the next layer. The output will be initialized in the initial stage. It will be given as a 0, so that if at all there are any missing or duplicate values, it can be ignored in the next level. So after creating a fully connected layer, we can compute then return final classification outputs. For this, we will be using the entropy loss and compute the mean of the losses. We will be calculating all the mean and the uh, entropy loss. For this, we will be having TensorFlow versions where we can initialize and have the library of a TensorFlows. So for this, first we will be training and testing this CNN model in CIFAR 10 dataset. For this, we have nearly 5,000 steps in it. Then we can use a different session of it where now we will find the accuracies of it. And for the finding of the accuracies, we can have first we will initialize all the variables in it. After loading the images and giving a shape, weight, and length of different types of images, we will be initializing the variables. After initializing the variables, each batch will be having 100 images. Like there are number of batches like batch 1, batch 2, batch 3, and so on. Like that, each batch will be having 100 images. Then this model will be trained and will be dropped out where almost 50% of the value will be dropped out. And for that, we will be running and training the accuracy values where the maybe it can be delayed up to 0.5 seconds. And for the testing of the model, we will be blocking and running the code like 100 times at the last of the 100th image, where each match will be at the 100 images. For that, we will be printing on the step and using the format as I. Then we will print the accuracy. So for this, the equal matches and is there any differentiation or any problems, any accuracy means and medians are calculated in that. And we can see that in each step, we can see the accuracy of image. So for example, here we can see that on the step 4300, we can have the accuracy until 0.6. In step 4400, it's 0.67, like that. In 100, we have 0.3. In 200, it's 0.4. In 300, it's 0.48. In 400, it's 0.49, and it still go on. So that's how we get the accuracy. We can see that this model's predictive power can be increased by using more optimizations, more training data. We can include more training methods and more design which can be performed. So in an overall conclusion, I can say that project like how the CNN models can be developed and how these data sets can be helpful, how these CNN layers can be more easy for the prediction of this data set, as this is an complex data set.